Good day. Today I'm going to be discussing chapter 6 of Java using the Java library. So, in this chapter, we basically um, continuing from chapter 5. We were building the simple startup game. So, in the last game, in the last chapter, we had a bug in the game where if you make the same if you make a hit on the same grid more than once, it gives you a second hit, and then on the third one, it still gives you a kill, even if you make a hit on the same grid. Whereas it should be a hit on 3 different grids to sync the start up. So, in this chapter, we're basically fixing that bug and adding new code to enhance the game. So, how the game initially worked is it's like a simplified version of Battleship. So a player tries to sync 3 fictional startup companies by guessing their hidden locations that they are on the 7x7 grid. So each startup occupies 3 consecutive cells, either horizontally or vertically. Then the player enters guesses like A3, F5, and the game responds with hit, miss, or kill, depending on whether the guess hits part of the startup, misses entirely, or sinks one completely. And then the game continues until all startups are sunk. So when you make 3 different guesses on a grid, it basically sinks the ship if those guesses are correct. And yeah, that's basically how the game works. So in order to fix that bug, we have to use an array list within the code. So the difference between an array list and a regular array is regular array has a fixed size. So once you create a regular array, you can set a specific size, and that size can't be changed. So a specific limit to how many values can be placed within the array. So as you can see here, we have this array numbers, and we set the fixed size over here, as you can see. Whereas with an array list, it's more dynamic, so it can grow and shrink. It's flexible. We can grow the size and shrink the size of the array by adding different types of values within the array as much as we can. So yeah, that's basically the difference between them. You can see in the syntax over here as well. Alright, cool. So let's jump into the code and see how the code works. So firstly, I have my startup bus, which is it's basically the main game controller. So this class is basically where I run my game, and it controls the game. It runs the main loop, it checks guesses, and it prints the final results. So it manages the list of startups and tracks the number of guesses. So how it does that? First, we import java.util.arraylist so that we can declare an array list, which will basically store the different startups in our array. So over here we have our class startup bus. We have 3 different. We first have an object, game helper, which is helper, which is basically coming from our game helper here, which is what I'll discuss. When we have the array list that we declare here, it's gonna list the 3 different startups. Then we have number of guesses variable with the default value of 0. Then over here we have a method. This method, setup game, is what sets up our game. So within this method we create 3 startups and assign them random locations on the grid. So we create 3 startups here. So we declare the first startup object and we use set name to give that startup a name. Then we do the same for the second object, give it a reference variable of 2. Using that reference variable, we call the set name method to give it the name. And then we do the same for the third startup. Then we call the add method for each object in order to add the in order to add each startup to the startups array list, as you can see here. So all these startups are going to be added to this array list using the add method. Then we have here instructions for the game. And here's a for loop where the startup in startups, which is the array list. So this loop happens where the array list new location is declared over here, and basically within here we use the place startup method. So we're calling that method to basically ask the helper to pick 3 spots on the grid. So we declare 3 here as an argument, and place startup method comes from our game helper, which is over here. So this method that is called there is just gonna place a startup of a given size on the grid without overlapping. So it's just gonna place a startup on the grid. That's basically what this method does. So we call that method, and we basically give it a value, give this parameter a value of 3, which represents the startup size, so the size of the startup, meaning that it's going to have 3 locations. So we call that method there, and we save the startup size to new location. Then we call set location source and give it this new location over here, gets passed here as an argument. When we call the set locations method, set locations comes from our startup class. So this set locations method is just setting the startup locations on the grid, the startup's location on the grid. So yeah, it just sets that location on the grid, and yeah, we basically call that here within this loop. So that's how you set up the game. Then over here we have a start playing method, which will basically be the main game loop. So you keep asking for guesses until all startups sunk. So within this while loop, we're saying while startups is not empty, that means that the game is still running. So you can still give the user a prompt for them to enter a specific guess, because the startups array list is basically not empty, meaning that all grids were not hit. And then after that, finish game method is called once all the startups are hit, and that's this method here that's called finish game, which ends the game. Then we have the check user guess method. This is just gonna check the user's guess against all startups and print the result. So here we increment the number of guesses. When a user makes a guess, this gets incremented by 1. We have a default value for this result variable set to miss. In this for loop, it's saying for startup to test in startups. So while it's looping in the startups array list, we declare variable results, which stores the result of the user's guess from the check yourself method being called. So if the result equals to hit, it breaks. If result equals to kill, then we remove the startup from that startup's array, and then we just print the result. Then finish game is just displaying the final message after a game has ended. So yeah, so it displays either this message or startups are dead. Based off this condition, it displays these messages, also displays this. This is the main method which runs the game, essentially. Then we have our startup class. So the startup class represents a single startup company. So one startup basically is what it represents. So it stores its location on the grid and its name and checks whether a user's guess hits, misses, or kills it. So basically here we basically import the array list so we can create an array list. Then we declare our startup class. We have here firstly here we have our array list location sols. This is basically the grid spots where the startup is placed. Excuse me. So for example, A3, A4, A5. That's placed within location sols. And then we have private string name, which is basically going to store the startup's name. We have string user input, which is just going to store the user's latest guess. Then we have set locations method, which is going to set the startup location on the grid. It has the array list, the array list string lock. So basically has whatever values placed within lock. It has that as parameter. Then we declare this. We place the whatever value is being stored into this parameter is being placed within this location sols variable, and then now it holds the location sols. So where set location sols was called was basically let's see. Here, set location sols method was called here, and it had a argument of new location. And you know that new location was basically holding the value we got from this here, which is basically the new location. So that's saved there in our location sols array, which is basically just gonna hold the grid spots for the startup that is placed. Then we have set name, is just gonna set the name of the startup. Then we have the check yourself method. It's just gonna check if the user's guess is a hit, miss, or kill. So does that. Firstly, over here we have user input as a parameter, and it holds the user's input when we call the check yourself method. So user input holds user input, and the default value of the result variable is set to miss. Then we have this index variable which stores the location sols, the user input in the location sols. Then if index is greater than or equal to 0, it basically removes the index, the location, the sol that is hit, essentially. If the location sols is empty, the result becomes a kill, and we print this out over here. Else the result is a hit, because not all 3 sols were hit, and then we return the result. And that's the startup class. So mainly the startup class is just representing one single startup company, and it stores the location on the grid for that specific startup and checks whether the user's guess is a hit, miss, or kill. Then finally we have our game helper method, our game helper class. So game helper is handling utility tasks like placing startups on the grid without overlap, converting grid positions to readable coordinates like B4, so basically just formatting it to the right format, and getting user input, and it ensures that startups are placed logically and fairly. So we import this here, then game helper. Let's actually research what we imported. What import is this? So this line, this import is basically a wildcard import from Java's utility package. It brings in all classes from java.util, which includes commonly used data structures and utilities such as ArrayList, HashMap, and all of these scanner. So it's importing, it's basically importing different data structures or different classes per se that come in one package. So it makes it easier to use these classes without importing each one individually. So we're importing all of these as a group so that we can use any of these classes. So if we want to use user input, we can use scanner. If we want to use an array list, we can use this. If we want to use a randomizer, we can use random, and so on. So that's what this import is for. So we declare our game class, and we have all of these variables declared here. Private variables, meaning that these variables can only be used within this class. So firstly over here we have alphabet, which is gonna store. So this is a static variable, I believe. Yeah, it has alphabet here, which basically stores the columns from A to G. This private variable grid length, ensuring that the grid is 7 cells wide. Private static final int grid size, which represents a 7 by 7 grid because we declare 49 as the value there for the startup game. Then max attempts, which has a value of 200, meaning that you have a maximum attempt of 200 in the game. Horizontal increment, which means moving 1 to the right. Vertical increment, which has the value of the grid length, which is 7, meaning that you're moving down because it's vertical on the grid. Then we have this variable, actually an array, which stores integers, and it has the grid size. Then we have this randomizer to pick random positions, and the startup count with the default value of 0, which keeps track of how many startups are already placed and helps alternate direction. Then over here we have our get user input. This is going to prompt the user and return the input as a lowercase string. So it's just prompting the user to make the specific guess they need to make in order to get a hit and a kill. So in order to do that, we use scanner to read the user's input, and then we return next line 2 lowercase, meaning you can put lowercase values. Then we have this method over here, which is basically place start up. So this is gonna try to place a startup of a given size on the grid without overlapping. So that's what this method does. Yeah, and this method was basically called in this class. Let's see. Yeah, it was called within the set up game method in order to place a startup on the grid, and we basically declared here 3 as the argument, representing 3 spots that are picked on the grid for the startup specifically. So that's how we're able to place the startup. Here we have this startup codes, which basically holds the current candidate coordinates. We have this variable attempts, which stores the attempts. Boolean value, startup counts gets incremented every time. And yeah, then this while loop here, which is the main search loop, is gonna also get a random starting point over here. Here we create an array of proposed chords. In this if statement, basically it's saying if the startup fits, if startup fits is true, then success gets this value over here where the chords available method is called. This chords available method is declared here. It's just gonna check if the proposed grid positions are available or not. So yeah. Then we save the position to the grid. Here we have our array list alpha sols. Then here we print place startup at whatever alpha sols holds, basically, and we return alpha sols. Startup fits method is gonna check if the startup fits within the grid boundaries, basically. So let's see. Startup fits. Yeah, so it's just basically just gonna check if the startup fits within the grid and if it has specific grids to fit on, basically. So in order to fit properly on the game board without going off the edges, so if the ship is placed horizontally, it makes sure the first and last positions are in the same row, so the ship doesn't wrap around to the next row. So that's the main idea of this method. So yeah, over here in this if statement is checking if increment is equal to horizontal increment, meaning that it's a horizontal, and if it is, we'll return calculate from index method, which is being called, and the value we get from it. Then here in this method, we're checking if the proposed grid positions are available. So we know that method was called here. So we check that by using this for loop, and it's saying for chord in startups chords, if the grid indexed with chord is not equal to 0, then we return false, meaning that the chords are available. If the chords is not available, then we return true. Here we have a save position to grid, which is gonna mark the grid positions as occupied over here. So basically, once a grid position is occupied, so once a startup is placed on 3 different grids, right, then those grids are occupied basically. But in order for them to be occupied, you need to call the save position to grid method. Then we have this convert chords to alpha format. It's just gonna do a format where it changes the format of the user's input. Instead of them just putting a number, they have to put the actual grid and the number. So A3 for instance. So yeah, that formats that. We have a get alpha chords from index, which is just gonna convert a single grid index to alphanumeric format. Calculate from index is gonna calculate the row number from a grid index. It does that by dividing index with grid length. Grid length was basically declared here, and we know that 7 representing 7 cells wide for a grid. Then get increments is just gonna alternate between horizontal and vertical placement for the specific startup. It does that by using an if statement, which is basically saying if the remainder of startup count divided by 2, so whatever value is in startup count is divided by 2, and if the remainder of that is equal to 0, that means it's an even startup, meaning that we return the horizontal increment. So we place the startup horizontally on the on the grid. If that's not true, we place the startup vertically on the grid. And that's basically how the application works. So let's see how the interaction works in the game. So this is where I run my main this is where I run the actual game. And once you run the game, you can see over here instructions. Your goal is to sync the 3 startups, and these are the 3 startups that are declared on the grid. Then we have to try to sync them all in the fewest number of guesses, and then we place the startup. So over here it's giving us basically the answers. So yeah, we can these are the grids that the startups are basically placed on. So for instance, the first startup is placed on F2, F3, F4. Here C4, D4, E4, meaning that it's probably vertical. Here this is horizontal because it's A4, A3, A4, A5. So when I guess the first guess, A3, meaning I hit I basically hit the first grid essentially. So once that's hit, then that means what that means is that grid, that part of the startup is a hit, and the user gets a hit because their guess was correct essentially. So then after that, in the previous chapter we had a bug where if we made the same hit on the same grid, it still gives us the result of a hit. But here we fixed that using the array list. So when I say A3 again, it becomes a miss because this is no longer available on the grid because we hit it. So the next guess would be an A4. That becomes a hit, and then A5 is a kill, and now I sunk the whole ship. So yeah, this becomes a miss because of my quotes what's it called? Let me see. Convert quotes to alpha format method, meaning that I have to enter A4, not just 4, because of this format. So yeah, and then when I guess all the grids, the correct ones, and get 3 hits, I get a kill, and the sync, and the startup syncs basically. Yeah, that's basically a summary of chapter 6.